So now we're going to get into tutorial 1 and then segue from that right into the homework. So this time tutorial 1 and homework 1 are the same assignment. You'll upload them together when you're finished, but also I want you to upload your progress wherever you're at the end of class today, because that will count as your attendance for today, and also that'll give me a chance to see how far you got with it during the synchronous meeting time. But that's fine. If you only get through a portion of it during class today, that's absolutely fine. So there's the tutorial that's coming up in this video, but remember that you can pause and rewind, and you can take as long a pause as you need. I mean, take breaks as you need them. I hope you have been already. And then when the tutorial is done, you should have a completed file that is exactly what I built and that functions exactly as I built it. And then from there, you'll open up the homework assignment that I'm going to send you by email and complete that homework assignment by the deadline posted on Blackboard. But as I say, definitely upload what you have before the end of the synchronous class meeting today. Also, you're going to need some files for this tutorial that you download from Blackboard. So go to Course Documents and download the file Week 1 Models to your computer. It's a zip file, so you'll need to decompress it, and it's a folder that has 3D models in it that we'll be using in the tutorial today. Okay, let's get started with Max, which is the software we're going to be using throughout the semester. The beginning place in Max is to create a new project. We go to File, New Project. When you create a new project, this is going to create a folder on your computer. So it's important that you be mindful of where that folder is being created. Max wants to put it inside the projects folder, inside the Max 8 folder, inside the documents folder, inside your home folder, which is absolutely fine as long as you know that that's where you're saving it. But you can also choose a different location. For instance, I'm going to put mine into my class folder for this class, multimedia. And I'm going to call it Tutorial 1 Project. And that creates the project window, which right now is blank. The project window is where all our files that are part of this project are going to be gathered. And if you ever need to get back to the folder where your project is stored, you can always click this small icon in the lower right corner, and that will call up the folder that contains the project folder that you just created. So let's add some files to our project. Let's start with the Week 1 models that you downloaded from Blackboard. You can highlight all of those, drag them, and drop them into the project. And now they are now part of the project. They haven't actually been moved to the project folder yet. We'll cover that later, but they're now accessible from the project. We can close the media tab so we don't have to see them, but they're still there in the project. Now we actually create our Max patch, which is where we build our actual multimedia project. We click the plus button, say add new file, so we'll call it tutorial 1 patcher to differentiate it from the project. And you don't need to add the word patcher, but in the beginning, if you want to make sure you know what's what, you can add patcher to it and save it. And now this is the blank canvas, the patcher file in which we do all of our work in Max. We've got a couple of housekeeping things to do before we get into creating some multimedia. First thing you want to do under the options menu is make sure that auto fix width is turned off and segmented patch cords is turned on. If you don't do that, the things that I'm doing on the screen will not match what's happening on your computer. So it's really important that you change that setting. And since we're in tutorial mode now, just in general, you want to pause a lot and rewind a lot, as much as you need to. Take your time with this and really make sure that everything I'm covering, you try it, you do it, it works, you understand it, you can take some notes on it. That's going to be important throughout this process. So the next kind of housekeeping thing we want to do before we get started is we want to be in a Monospace font. We want to be in a font where the spaces and all of the letters are the same width. That really, really helps in Max because spaces are super important. So click the little paint bucket up here and switch to any Monospace font. The one I like to use is Monaco. That's a good-looking Monospace font. You might not have Monaco on your computer. That doesn't matter. Just go to Show Fonts and pick any Monospace font. Any font that has the word mono in the title will be a Monospace font. Also, American Typewriter and Courier are both Monospace fonts. There's Courier, also Courier New. So you can choose any of those fonts as long as the spaces are the same width as the letters. And you can also make it a little larger. I like to run mine around 14-point size. And I'll do Andel Mono. And then you can close out this formatting bar. So now that's our basic housekeeping. Now, what is this blank screen that we're confronted with? Well, one of the wonderful things about Macs is it makes no assumptions about what kind of project we're going to make or how we're going to go about making it. It starts with a blank slate. So we could be starting a music project or a sound project or a video project. It turns out that we're starting a 3D graphics project. So we will put the objects, put the nodes into this space that are related to the kind of work we want to do. So what are those nodes and how do we make them? Well, the first fundamental node for a 3D graphics project is the 3D graphics world in which our objects are rendered. So we're going to create that first. To create a new object, we can either click this icon right here or hit the letter N, and it will create a new object box and put the cursor in there for us. All objects that deal with imagery start with JIT period, JIT dot. So when I type JIT dot, it gives me a menu of all the various JIT dot objects. It's a very long list, so it's not particularly useful until I type some more letters. I know I want to create a 3D world, so I'm going to type in a W there, and it suggests for me JIT.world. That, in fact, is the object that I want. I can double-click it from the list, or I can hit return, and it'll create the JIT.world object. And then as soon as I hit return or click away from the object, my 3D world is created, and a window into it is created. And that's great. I now have a place where I can do 3D graphics. But this world isn't quite done yet for us. It needs a few attributes changed. One of the problems with this window is if I click back into my patcher to do more work, the window falls behind. And if I click over into my project, now the window is entirely gone, and I have to go under there to get it back. But I can make this a floating window that floats on top of all others, and I do that by setting an attribute. So I type the @ sign, just like the email @ Shift 2, and I say @ floating. And notice that it knows the attributes of the object. And as soon as I type the F, it gave me all of the F attributes. And as soon as I typed the FL, it knew I was talking about floating. So I can actually just type the FL and click there, and it'll fill in the rest of the letters for me. And that's useful because it keeps you from misspelling the attributes. So now I have the floating attribute, and this happens to be an on-off attribute. It can either be floating on, meaning the window will float on top of other windows, or floating off, meaning it will fall behind other windows. And that is called a Boolean. It's called a Boolean when there's only two choices, and the true choice is represented by the number 1, and the false choice or the off choice is represented by the number 0. So JIT.world @ floating, and now here's that important space. I put in a space and I type 1. So JIT.world @ floating space 1 is going to turn on the floating attribute of the world. And we can see now it doesn't fall behind. So two other attributes that we're going to add. We're going to add enable 1, and this turns on rendering, turns on graphics rendering in that world, so our objects will actually appear. And we're going to turn on FSAA, full scene anti-aliasing, which will just make things look nicer. So now we have a 3D graphics world into which we can render stuff. And if I just take an object from our list of objects here and drag it into the world, it's rendered into the world. And that's really nice. So I dragged in this 3D model called casual1.obj, and it immediately created for me the jit.gl.model object and rendered that model into my world. So on the one hand, that's very exciting. We've created a 3D graphics world and we've put an object into it. So it looks very flat, It looks like a paper cutout. It has no dimensionality. And that's because it has no material. In a 3D graphics environment, an object needs a material in order to reflect light. So we can add a new object here, jit.gl.material. And now we're going to make our first node connection. I'm going to connect the outlet of the jit.gl.material by clicking, and that creates a patch cord, to the inlet of the jit.gl.model. And I will click again. And now we can see that the material has been applied to the object, and so there's some lighting reflection on the object, and it appears much more three-dimensional. Now, sometimes when you click and want to create a patch cord, you get stuck and you got nothing to connect it to, and you don't know how to get rid of it. So you can just hit the escape key, and that will delete that patch cord. So let's give ourselves the ability to change our view a little bit here. I'm going to introduce a new object called Jit.gl.Handle. And it's a very versatile object that could be used in a number of different ways. The way we're going to use it right now is to connect it to the world itself. And once we've connected a Jit.gl.Handle to the world, we can click and interact in the world's window. If we just click and drag, it will rotate the world. If we command click and drag, it will move the world in the X and Y dimensions, and if we option click and drag, it'll move the world in the Z dimension. Now, this is not the same as moving a camera around. We're going to look at that later. So if we get ourselves in kind of a messed up rotation, or just want to reset things, we can send a message to the jit.gl.handle that will reset it. And this brings up the concept of messages. So right next to the object here, our next thing is a message. And objects are nodes that do things. Messages are instructions that are sent to those nodes. So if we create a new message by either pressing this button or positioning our cursor where we want the message box and hitting the M key, we get an empty message box, and we can put a message to an object into that box. So we'll put the message reset into a message box, and we'll connect that message box to the object that we want to reset. So now this message becomes a button that will send the message reset to the jit.gl.handle. And in order to press the button, there's two ways we can do it. One, we can hold down the command key, which is the control key on Windows, and click it, and it will send the reset message to the jit.gl.handle. Alternatively, we can lock our patch by clicking this lock icon down here in the lower left corner, lock the patch, and then we don't need to hold down the command or control key in order to hit the reset button. So just to review what the keys are, if we click and drag with no modifier keys, that's rotation. If we click and drag with command held down, control on Windows, that's moving in the X and Y dimension. And if we click and drag with option held down, that's moving along the Z dimension. So let's add another model here, Casual 6. And notice that the Casual 6 model comes in at the same location as the other model. At the 0, 0, 0, the center location of the space. She has no material, so we can use the same material and actually apply it to both models. And now we want to obviously reposition one of the models. I mean, this is kind of interesting to have them occupying the same space, but we do want to reposition one of these models. So there's a number of ways to do that. The most basic way is to use the @position attribute to change the position. Now let's talk about positions in 3D space. The center of the space is 0, 0, 0, meaning 0 on the x-axis, 0 on the y-axis, and 0 on the z-axis. The x-axis is the right and left axis. The y-axis is the up and down axis, and the z-axis is the depth axis. So let's say we wanted to move her 1 meter to the right of center. That would be position 1, 0, 0, meaning 1 meter to the right, no meters above, and no meters towards us. And we can see position 1, 0, 0 positions her 1 meter to the right of center. So if we wanted to position her 1 meter to the left of center, that would be position -1, 0, 0, and she's going to move over to the left side. And the same thing for the y and the z dimension. So if I want to position her closer to us, I can increase her z dimension. If I want to move her 2 meters towards us, I can say 1, 0, 2, and that will move her 1 meter to the left of center and 2 meters closer to our viewpoint. And of course I have the vertical dimension as well. So if I want to move her down by a half a meter, I can say negative 0.5 on the y. And now she is 1 meter to the left of center, a half a meter below center, and 2 meters towards our viewpoint, away from the center. And the negative numbers work the same. If I wanted to move her 2 meters further from our point of view, and it looks like she's actually just smaller, but if we rotate, we'll see now she's actually just more distant. So that's one way to move. It's not a very interactive way to move because you've got to type the numbers in. And a lot of times you want that specificity. You want to be able to place things in very specific locations. But also sometimes you just want to be able to click and drag and move things interactively. And there's a couple ways to do that. One is if we have this yellow circle with a black arrow in it. If we click on that, it calls up a little contextual message. And one of the contextual messages is all of the attributes of the object. And if we select the position attribute from the list, it will create what's called an attrui, or an attr UI. And this is a box that will allow us to interactively change the values without having to retype them all the time. So we'll hold down the command key, click into the attr UI, and now we can drag the position. Now, when you're clicking and dragging, it's always a up and down vertical motion. So to move her up and down, I'm dragging up and down. But to move her left and right, I'm also dragging up and down with the mouse. And the key insight about these attr UIs and the number boxes that we'll look at later is the further to the right that you click, the finer your adjustment is. So if I command click there, I'm moving her in hundredths of a meter, centimeters. If I click on the 6, now you see the movement is choppier. I'm moving her in tenths of a meter. And if I click to the left of the decimal point, I'm moving her in entire meters. So where you click affects how smoothly the transitions will be between positions. Now, the one negative about using the attr UI to change the position is these values are not saved. If I save my patch, Command S, close it, and reopen it up, she resets her position to whatever the typed in attribute is. So if I want these things to be saved, if I find a position that I want to save, I need to unlock my patcher by clicking the lock here, go back to that yellow circle with the black triangle, click it, and say transform changed attributes to arguments. That will take the position I've entered from the attr UI and write it into the object. Here it is, position 0.7, negative 0.370. Notice there's a couple other things that have been written in here, like at fog1, at auto material 0, at lighting enable 1. Those are attributes that were actually written by the jit.gl.material object when we made the connection. They're only showing up now because we've selected to have all changed attributes turned into arguments. We changed some, and the jit.gl.material object also changed some, and now those are all written into the file. So now that these values have been transferred, if we save and close again and reopen, we see those values are retained in both the attr UI and in the object itself. So this is a way of saving the initial state of the object. So I mentioned earlier that there's a camera object that's distinct from the Jit.gl.handle, and it becomes a little frustrating after a while to always have to option click and push back in order to see your scene. The default camera location is a little bit too close to the action, so we're going to put in a Jit.gl.camera just so that we can set the default camera location a little bit further away from the center at position 005. So we're going to basically, the default camera position is 2 meters away from the center. We're going to set the camera position 5 meters from the center, just so our scene is a little bit wider and easier to work with. We'll be doing much more with the camera later. For right now, it's just a way of setting our default viewpoint a little further away. And the Jit.gl.handle still works when we have a Jit.gl.camera in play. They interact with each other. The one adjustment you might want to make to the Jit.gl.handle is to add a radius attribute and just make the radius of the handle a little bit larger, like maybe a 2 meter radius, just so it's a bit easier to grab when the camera is further away. And you can change that radius to whatever's comfortable for you. And also, I'm unlocking and locking the patcher using a shortcut. I'm holding down the Command key and clicking in the blank space to lock and unlock. Another shortcut, if you want to use it, is Command E. That will lock and unlock the patcher, and that just saves you the time of mousing down to the corner. And most of the time you can operate your patcher unlocked because you can hold down the Command key to press buttons and to scroll adder UIs. So let's look at a few more attributes that we can modify on these models. Once you have an adder UI, you can command click and pull up the entire list of attributes directly from the adder UI. So you don't have to go back to the yellow circle with the black triangle and go to this attribute list if you don't want to. You can always command click here. And we have some good attributes like rotate XYZ, which don't use rotate. Use rotate XYZ because it's much easier to manage than rotate. Rotate XYZ is the more expected kind of rotation, where rotating on the y-axis will spin around the vertical axis, and rotating on the z-axis will spin around the z-axis. And so that's why rotate XYZ is a nice type of rotation. One thing I should also tell you about the adder UI is if your patcher is locked, you can type numbers into the adder UI as well by clicking the arrow. See how that arrow turned yellow there? If I want to reset her Z rotation to 0, I can just type 0, return. And just like position, the rotate values will not be saved until we unlock, click the yellow circle, and transform changed attributes to arguments. See, now the rotate XYZ has been written into the object. You can also have multiple adder UI connected at the same time. You can click on your adder UI and either Command D to duplicate it, or Option click and drag to create another one. Or you can go back to your yellow menu, go to Attributes, and create a new attribute for anything. Doesn't matter which one you pick, and then Command click it to choose what you want. So rotate XYZ we have, so we'll do position. And I'm stretching these out wide to make sure I have enough space to the right of the decimal point to make fine adjustments. So now I can control rotation and position with 2 connected adder UIs. When I get something I like, I unlock the patch, click the yellow circle, transform change attributes to arguments. And one thing to note is if you Command D or Option click and drag, your adder UI will not be connected. So you do need to make that connection. And you'll end up just stacking your adder UIs because you tend to have a lot of them after a while. And scale is another 1. Now, with human models, there's a limit to how much modification of scale you can do without things becoming strange. But with non-human models, you can do quite a bit with scale. So let's for instance, bring in the open box. I can't drag it until I'm unlocked, so I have to unlock the patcher, drag in my open box model. I'll connect it to my material. I don't have to. Or I could connect it to a different material. And I can take all three of these adder UIs. I can Command D to duplicate them, bring them down here, and I'll connect all three of them to my new model. And a shortcut if you want to connect multiple things is you can hold down the Shift key. So I can Shift, click, 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 and then since I have a cable hanging out here, I hit Escape to get rid of it. So now I can rotate this box and position it and scale it. And so now my characters are inside of the box. And then as with before, if I want to lock these settings, I need to unlock my patcher and transform changed attributes to arguments. And I could see that if I want something sort of realistic, if I want them standing on the bottom of the box, I will have to make some adjustments. I can position the Y of the box up and position the Y of that model up and check and see if I did a good job there. That's great. And now they're standing in the box. And again, I go back and I transform change attributes to arguments. Transform changed attributes to arguments. And then when I save this and close it and reload it, it will come back with all those settings intact. And because of my camera position, I'm not all the way zoomed in on those figures like I was before. So color is a huge topic, and we're just going to scratch the surface of it today. If we want to color these objects, there's two things we need to do. We'll take two of these adder UIs, we'll duplicate them, connect them to the object, escape to get rid of the dead patch cord. I'm going to lock my patch, and then I'm going to go in here and choose color, and I'm also going to choose material mode. And the reason for this is right now, if I just change the color, actually the color of the object won't change because the material is determining the diffuse color of the object. So I need to choose material mode 0, ignore, and now I can change the color. And I can change the color using the crayon box. I can change the color using this sort of conventional color picker slider. The way you should probably look at it, though, is in terms of RGB sliders, because this is the way Max handles color internally. So how I got here, I clicked on the color bar, I clicked on the second tab, I selected RGB sliders, and now I'm going to click on the gear tool and go to floating point representation of color. Why I'll go through all this trouble? Because you're going to need to learn how to think about color in terms of RGB values between 0 and 1. So for instance, red is 1, 0, 0. Red value maximum, green value minimum, blue value minimum. So yellow is RGB 1, 1, 0. Maximum red, maximum green, no blue. Purple is red plus blue. And every color can be made by some mixture of red, green, and blue, because red, green, and blue are the primary colors of the computer. They're the primary colors of light, in the same way that red, yellow, and blue are the primary colors of paint, or cyan, magenta, yellow, and black are the primary colors of offset printing. So right now you can hand enter these colors, but once we start working interactively, we're going to have to be thinking mathematically about the colors. For instance, all shades of gray are achieved by setting the faders the same. 0.5, 0.5, 0.5 is middle gray. 0.23, 0.23, 0.23 is going to be a dark gray, etc. Also, white is achieved by the presence of all color, and black is achieved by zeroing red, green, and blue. And of course, once you have a color that you like, you unlock your patch and say transform changed attributes to arguments. Now, of course, this is just day one. There's other ways to save your values, and of course there's ways to animate them and make them interactive. We're just dealing with very simple stuff right now. So we're going to cover just a few more things in this first tutorial. One thing I want to point out is if you're done with an attribute, like this material mode attribute, we're not going to need it again, you can delete it. Since it's already been included in the object's attributes, the attribute is no longer necessary. So I'm going to add a few more ideas here. One of the things I'm going to add is how to deal with the mess. I've got a whole bunch of stuff here, and it's taking up screen landscape. So I can highlight it by drawing a box around it, and I can encapsulate it. I can stick all of these nodes inside a node. And we do that by saying edit, encapsulate. And nothing changes in the image, but my screen has a lot more space on it, and I just have this object that says the letter P. If I put in a space and give it a name, call it people underscore and underscore box. When I lock my patch and double click this, all of my people and box stuff is inside this sub patcher. So now I have space to actually spread out again if I want to and make things very clear and readable. Notice also that my font preferences are reset inside of this subpatcher. But really, since everything is working the way I want it to, and I'm kind of done with this, I don't need to do further work here. And so the entire people and box part of this is now encapsulated, and I've regained all of this landscape on my screen. I'm going to use that landscape to show you a couple more objects. If you want to create basic shapes, just your simple cube, sphere, torus, cylinder, and the Platonic Solids, there's a couple objects that'll do that for you. One is jit.gl.gridshape, and jit.gl.gridshape is by default a sphere. And if we add a material to it, you'll see that it's a three-dimensional sphere in our space. If you look at it, it's a little bit coarse. See how it's got kind of flattened edges on it? It's not a very high dimensionality sphere. We can fix that with the @dim attribute. Just crank it up to 50 by 50, and that'll make a much smoother dimension sphere. And we'll talk a little bit more about dimensionality of shapes later, but for now just know that you can smooth out any rounded shape by increasing the dimensionality. And I can change the shape. It's by default a sphere, but I can say, for instance, @shape cylinder at scale 0.1, 0.1, 10 at rotate XYZ 90, 0, 0. And now I've created this pillar that passes through that model and through the box. And of course I can create attrui. The other way you can create an attrui, by the way, is making a new object and typing attrui. That will also create an attrui. And with these, you can change your color freely without needing to modify any other aspect. So the shapes that are available: sphere, torus, cylinder, open cylinder, cube, open cube, plane, circle, cone, and capsule. The other shape generator that we have for generating the Platonic solids is Jit.gl.plato. And we can hook that up to a material as well. And this generates the Platonic solids, which are all of the solids that are made up of the same shape on every side. So shape 1 is triangles on every side. At shape 2 is a cube, which we already have, but at shape 3 is an 8-sided figure made of triangles. And at shape 4 is a 12-sided figure made of pentagons. And at shape 5 is a 20-sided figure made of triangles. So these are the Platonic solids, and they're accessible via jit.gl.plato. So just one final thing I want to mention before the end of the tutorial is this comment that I placed into the patcher here to show the names of all the different shapes. That comment is created by hitting the C key, and you can type any comment you want, and it will stay in your patch. So that's the best way to take notes in this class, is to take notes in comments right in your patches, right in the tutorial patches. And when I say you have to complete the tutorials exactly as I've done them, that's true, but you can add all of the additional comments you want. In fact, I would really like to see your comments in the patch. So having completed the tutorial, having built everything that I've built, and having transformed all the changed attributes to arguments so that you know you haven't missed anything or lost anything, having encapsulated the people in the box, and actually just to practice encapsulation, you can certainly encapsulate these shapes as well. Edit, encapsulate. And when you're ready, save this tutorial 1 patcher. So then moving on to the homework, I'm going to give you a series of images to recreate using the tools that we've studied in this tutorial, and then also give you a couple of creative assignments where I'll just be giving you an inspiration or a direction, and I want you to create the image. So here's the first image, and we'll do the first one together just so you can see what the process is like. So I give you this image and I ask you to make a patch that creates this image. Okay, so we're going to create them within the same project. This is the tutorial 1 project, but it's also going to have the homework saved within it. So we'll say add new file, and we'll call this homework 1. Save it into my project. And now I don't have to start from this blank screen. Why? Because I just did all this stuff that I can copy and paste. So I'm going to open back up the tutorial 1 patch, and I'm going to unlock it, and I'm just going to copy the camera, the handle, and the world. Edit, copy, and I'm going to paste them into my homework patch. Now, when you redo the tutorial, you will want to retype all of this because you want the practice building it. But when you're doing a homework assignment where you've got several of these to do, definitely copy and paste. I'm going to change my font and my size for readability. And here's my image that I've got to recreate. So what's in there? 6 cubes and a figure. Okay, so I'm going to break down this problem. What do I know about it? Well, I know that my main structure is 6 cubes, and then I can just stick this guy on top. So I'm going to do him last, and I'm going to do the front row of cubes first. So set this aside and say jit.gl.gridShape is what I'll start with. At shape cube. Good. That's a good start. There we have a cube. Aha. So it doesn't have any shading, so it needs a jit.gl.material. And again, if you didn't remember that, you can definitely go back to your tutorial 1 patcher and look at it, or even copy it. That looks right. So now I want to position these cubes. I could certainly create another one and hook up an adder UI and position it until I get the right. That looks about right. 2.1. Okay. Transform change arguments to attributes. Okay. Looks good. I'm on my way to having this completed. So now I can just think about the fact that, all right, if this one's 2.1 meters to the right, this one's going to be the black one, this one's the dark red one. So the bright red one is going to be 2.1 meters to the left. That's negative. Okay. And then I need a row behind. So I can take the 3 that I have here and I can just Command D, duplicate them. Hook them all up to the material as well. And I'm just going to shift them back. So on the Z dimension, by the same amount, negative 2.1 meters. Aha. Negative 2.1, and this one will be at position 0, 0, negative 2.1. Great. Okay, I'm well on my way. I have the basic 6 cube structure worked out here. So moving on with this, I need to deal with the color. Well, this one looks like it's primary red, so I'm going to start there. Which one is that one? That one's this one. So you know what I'm going to do? I'm going to lay these out in the same arrangement that they are on the screen so I don't get confused. It's this one, this one, this one, this one, this one, this one. So now these match the screen arrangement. That's very helpful. Okay, so this is the one that's red. I know that color. That's at color 100. Now, I could certainly use the color picker to figure out the other colors, but there seems to be a pattern to the colors. This one's black. That one's white, so I know those values. This one's at color 111. This one's at color 000. Okay, good. So now I just need to fill in the other values? Well, this middle one is a darker red, so let me guess that it's half as red, a red that's half as bright. So that would be color 0.500, a half as bright red. And indeed it is. Now this one in the back is pink. I don't know about pink, but this one appears to be maybe the same primary red potentially. So let's try that. That looks good. So now for the final one, some sort of pink. Well, that if I need to, I can just go to the @true for color and try and, well, wool, I just kind of hit it. I mean, that's almost exactly it. How did I get that? Yeah, that's it. It's like 1.5.5. Fine. Color 1.5.5. Great. Assignment done, with the exception of the fact that I need to add the person. I need to unlock my patch and add the person. Where are they? Ah, they're probably inside this cube. Let me see. Oh, that's not the right one. Yep, there they are. And I'm using Command Z to undo after I delete these things. So this is just a question of positioning. Okay, that looks good. And then let's look back at the image. Ah, he's quite small in relation to the cube. So we'll try and at scale. Ah, but now he's too high off of the cube. All right, so let's try a lower position. That looks good. What else do we know about this figure? Ah, he's not reflective, which means he's not connected to a jit.gl.material. So it looks like we need to do that. What was that attribute? I'm going to go back and look at it in the tutorial patcher. That attribute that has to be changed to allow models to be colored. Here it is, material mode 0. Okay, so I'm gonna go in here and make this model at material mode 0 at color 100. Done. So now save this as homework 1 in my project. And that's the way you're going to do all of the homework. Just if it's a matching problem, you're going to create an image that, within reason, as closely as possible. I mean, I was able to match it exactly because I made it 5 minutes ago. So you might not be able to match it exactly. That's totally fine. So you're going to have some matching homeworks and you're going to have some creative homeworks. They're going to be saved inside your project. And when you're done, you're going to compress your project folder and upload that to me via Blackboard. So here's how you do that last step. Before you close Max, after you've completed the homework, you want to go down to this little stack icon, Manage Project. Click it and consolidate. What that does is it moves all of the files you're referencing into your project folder. So let's take a look at the project folder. There's my tutorial 1 project, and it has moved a copy of all of the models into the project folder. And that's essential, not so much for this assignment, but it's an essential habit to get into because you're going to be grabbing files from all over the place. You're going to be downloading stuff from the internet, and they're going to be in different spots on your hard drive. And every time before you compress your folder and upload it to Blackboard, you want to make sure you consolidate. Once you've done that, you can close your project, go into the folder where your project is saved, and compress it. Now on a Macintosh, to compress a folder, you right-click on it, and then you say compress tutorial 1 project, and it's converted into a .zip file. And that .zip file, that compressed version of the folder, is what you upload to Blackboard. Now on Windows computers, depending on what version of Windows you're on, what software you have installed, your way of creating a zip file might be different, but the idea is the same. You're taking the entire folder, you're compressing it into a zip file, you're uploading that zip file to Blackboard as your submission. So have fun with this, dig into it. I'm available during the synchronous class time and during the office hours for your questions. Hit me up on Discord. And, I hope that you find this interesting and enjoy it. I'm delighted to have you in the class, and I think it's going to be an amazing semester. Please get in touch with me soon so I can meet you in person, and glad to have you in the class.